Good morning to all of you. Welcome to the free lecture series on the electrical engineering. Here now we are going to discuss the lecture number 3.6 that is called the armature reaction in DC machine. Armature reaction in DC machine. So for to understand this concept, we have to learn some definition. That is, the definition is like this. It may be defined as the effect on the main field flux. What is main field flux that we are going to discuss? Due to the armature flux called armature reaction and results a distortion in the resultant flux. So this concept that shows that the effect on the main field flux due to the armature flux is called armature reaction. So to understand this definition, we are just making this concept into 2 to 3 different cases. Where the first case basically we are considering a unloaded generator. That means there is no load is connected at the external periphery, and this rotor is rotated by an external prime mover. Since there is a constant magnetic field from north to south is like this, and the rotor is rotating, then these conductors under the influence of north and the conductors under the influence of south will experience induced EMF, and it can be like this fashion. There is induced EMF in the conductors, but since the load is not connected, so we having a armature current equals to 0. So at this case, we are only having a one flux is there, that is called the main field flux. This is called the main field flux from north to south. So we can say that the main field flux like this. This is called main field flux phi A. Since the load is not connected, so there is a no current in the armature. Now consider the case 2. In this case, we are having a loaded generator. In this case, we have put a load on this section on the outer part, and this rotor is rotated at an external prime mover in a constant magnetic field. Then this conductor will experience a induced EMF. Since the load is connected, then there will be a path for the current. So we are experiencing cross and the dot like this fashion. We are experiencing cross and dot like this fashion. So it shows that there is a current in this loaded generator. So if we are just taking this armature part here, we are having, this is called field flux phi F, but there is a one additional flux like this, basically the cross and dot. Similarly the cross and dot. Similarly the cross and dot. So this having a clockwise of nature having a flux, this having a anti-clockwise nature having a flux. So the resultant flux is going to be like this fashion. So when the load is connected, rotor is rotating in a constant magnetic field, and there will be induced EMF, and there will be a current which cross and dot like this. So the resultant, the flux is basically like this fashion for the armature reaction. So when the load is connected, there are two kinds of the flux are there. The first is called the main flux, that is called the main flux, and the second is called the armature flux. This is called armature flux. And due to interaction of the main field flux and the armature of flux, there will be a resultant flux in this armature. This is called resultant flux, and it is the combination, and it is the influence of the armature flux and the main field flux that interact with each other, and it gives a resultant flux of phi r. So the flux which is coming from north to south and the flux which is coming from this section, which is called stator section, which basically interact with each other, and due to this interaction there will be a resultant flux going to be distorted like this fashion. So in this case we can say that the resultant flux is going to be like this. First we can draw the cross and dot in this section. Dot and cross, and the resultant flux is going to be like this fashion. This is called basically the effect of the main field flux due to the armature flux is called the armature reaction. Like this. This is the resultant flux. So this is our main field flux. This is our armature flux. Now the resultant is going to be like this. This is called resultant flux like this. This is called resultant flux. This is called armature reaction. That means due to coming of this armature flux, the actual field which is going from north to south in a straight line, now it is going to be tilted or going to be diverted from their actual path because of this armature flux, and due to this we can say that there will be a resultant flux going to be like this fashion. This is called armature reaction. In addition to this, we have to learn there are 2 or 3 important parts. It is called the first part is basically the MNA, and second is called the GNA axis, where the MNA axis is always perpendicular to the axis of the resultant flux. In this case, when there is no armature flux, then we can say that the main field flux is like this fashion, and this is called our MNA and the GNA. This is the called our MNA and GNA. So MNA is the axis which is perpendicular to the main field axis. It is called MNA, and GNA is basically the geometric neutral axis. It is always quadrant to the axis of the DC machine. So the GNA basically remains constant. Previously this is GNA and this is MNA. Now the resultant flux is going to be like this. It's going to be changed like this fashion. So what we can say, MNA is going to be also changed because the MNA is the axis which is always perpendicular to the axis of the resultant flux. Here the resultant flux is going to be changed. This is called our mu MNA. This is learn. So we can understand that whenever the field flux is there, also we can say that the MNA and GNA coincide each other. But when the armature flux comes into the picture, then the resultant flux is going to be like this. Due to the resultant flux, we are shifting the MNA like this fashion. So we having the new MNA axis. Since in order to make a sparkless computation, during this axis, we have to shifting these brushes also in the MNA axis. So we can say that our new diagram like this fashion, like this, we have to shift. Okay. Like this. We have to shift this. This is our new MNA axis. This is the MNA axis when there is no armature flux. This is called MNA axis. Here the GNA axis remains constant. This is our new MNA axis. And in addition to this, in order to make a spark-like computation, we have to shift these brushes also, like this. So if the brush is shifted, so we can remove this brush like this, and we can say that the load is connected to the like this. And this is our previous MNA new. So this is cross, 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 cross and cross. Dot, 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 dot and so the shifting of MNA gives our new direction of this armature of flux like this fashion. In the previous section we have learned this is called our field axis. This is called our, we can say that the armature flux when this is our MNA. Now the MNA is going to be shifted like this. This is MNA, new MNA. And we can say that this is the resultant flux. Now, as per the new MNA we have seen, this is basically this called the armature flux like this, and it is moving anti-clockwise. It is clockwise. So this is our new armature flux direction. So we can also say that there is a change in the direction of the armature flux at an angle theta. If we are just dividing this component, so we can say that it is called phi A sin theta. This is called phi A dash basically cos theta. So what we can understand like this fashion, whenever the load is connected, armature flux comes into the picture. It may interact with the field flux. It may generate the resultant flux which can change the direction of the magnetic field like this. And we can say that we have to shift the MN axis, and due to shifting of the MN axis, the armature flux is going to be shifted, and it can be divided into two components. The first component is called the phi A dash cos theta, and second is called phi A dash sin theta. This is called basically a demagnetizing component. This is called basically the cross magnetizing component. We have seen that the field flux is going to be from like this fashion, and this field flux is going to be demagnetized, means it can be opposed by this. This is the armature flux component, and this armature flux component. We can say that this is called demagnetizing component, which can demagnetize this armature flux, sorry, this field flux. And similarly, the second component is called, that we are calling as a, this is called cross magnetizing component, which always tries to cross magnetize this armature field of the flux. So we can say that the overall flux which is coming from north to south is going to be distorted, and it is decreasing. So the armature flux basically divided into two components, the demagnetizing component and the cross magnetizing component. Both the components are trying to reduce this armature flux in the cross magnetizing in nature or demagnetizing in nature. So this is the effect of the armature flux and this component to the field flux, so that the resultant flux going to be distorted is called armature reaction that we have learned. Okay. Now, due to armature reaction, we can say that the flux density in the one side of the pole is pole tip increases in the one side of the pole tip and decreases in the other side of the pole tip. We have learned like this. The flux density waveform basically is increases in the one side of the pole tip and decreases in the one side of the pole tip. This is our first drawback we have learned. And second, we have think that the MNA shifted to the new position, and to make a sparkless commutation, the brushes also shifted in direction of the rotation of generator. This we have already learned like this fashion. This is our new shifting of MNA like this fashion. And due to this, we have two components of armature flux, phi A sin theta and phi A dash cos theta, which always try to distort this armature, this field flux, and making the overall of the flux will be distorted. So we have learned that there are two things. So we can say that the third thing that we have to learn, the armature flux will divided into two components. It is called phi A dash sin theta, and we can say that the phi A dash cos theta. It is called demagnetizing component, and it is called cross magnetizing component. So these two components, phi A cos theta, or basically the phi A dash cos theta sin theta, always try to distort the resultant of the flux. So, and the thing is that after this, we having a distorted flux is obtained like this, which always distort the main field flux. So this is the concept of the armature reaction that we have learned. And in the next class, we will discuss about the effects of armature reaction, and the how we can improve this armature reaction, how we can eliminate this, that we have to go and understand. Thank you.